This particular problem has a fraction bar indicating division. Since we're dividing by an imaginary number that is actually a complex number, so it has a real portion and it has the imaginary number, we need to multiply by the complex conjugate, which is going to be almost identical, except instead of addition, it's going to have the opposite sign, which is subtraction. That makes it like we're multiplying to get a difference of squares. And so what we're going to have to do on this denominator is FOIL. 5 times 5 is 25. 5 times negative 3i is negative 15i. And then distributing the 3i times 5 is a positive 15i. Every time you multiply complex conjugates, these middle terms will cancel. And then we have 3i times negative 3i, which is negative 9i squared. Remember, I squared is negative 1, so this is really 25 minus 9 times negative 1. And the double negative here is going to make this 25 plus 9, because negative 9 times negative 1 will be positive 9. So 25 plus 9 actually gives us a denominator up here of 34. That removes our imaginary number from the denominator. Now let's distribute the numerator. 6 times 5 is 30, and 6 times negative 3i is negative 18i. To write this in standard form, we need to separate it into our real portion, 30 over 34, minus our imaginary portion of 18 over 34i. We can reduce those fractions to get 15 over 17 minus 9 over 17i as a final solution.